alright, let's start. الحين physics بشكل عام يكون في a lot of components انزين which you guys should already know. يكون عندكم a mechanical part وال electrical part. احنا today we will focus mostly on the mechanical part and we will start with the basics. But before even going into physics, you guys need to know some important concepts about how to يعني how to find the units, the proper units, how to measure, how to convert units. These are very, very important concepts to start with in physics. And if you guys don't know how to do this, it will be very difficult to solve in general. So first thing, we have a standard unit system, زين, which is also known as the SI system, اللي هو International Standard, زين. International Standard. This SI system المفروض سامعين فيه وايد، هو بما معناه إذا عندكم length إنزين it will be in meters، إذا عندكم time it will be in seconds، إذا عندكم شنو بعد، إذا عندكم mass it will be in kilograms not grams، it will be in kilograms، وإذا عندكم temperature this will be أو خلنا أسميه temperature with capital T. Temperature, this will be in degrees Celsius. وطبعا there are other units as well for other things that are general. بس هذيل هم الأساس, the very basic ones that you guys need to know. اللي هو length is in meters, time is in seconds, mass is in kilograms, temperature is in degrees. Sorry, it's not degrees Celsius, it's degrees Kelvin or just Kelvin. إنزين. This is the international standard units. These are known as SI units. فأنتوا دائما بتحاولون تحلون. You will try to keep everything in SI units because you will be able to solve correctly. وخاصة when you are going to go into dimensional analysis, which we will talk about earlier soon enough. هذيل يسمونهم basic units. يعني these are not derived units, these are already available. يعني ما تسوون له أي derivation. هذيل هم basic initial units اللي you have. So the way يعني هذيل اللي هم SI units. مثلا some derived units يكونون volume which is equal to meter cubed. زين. acceleration which is meters per second squared أو velocity which is meters per second. هذيلا يسمونهم derived units. ليش؟ لأن لو تلاحظون اليونت مالهم مأخوذ من standard international units أو SI units. إنزين. فعندنا two types of units اللي هو derived units وعندنا SI units. طبعا you guys need to know the basic ones اللي هم I have on the screen right now. These are very important. Moving on to dimensional analysis. شو معناته dimensional analysis؟ الحين most of you have seen this equation which is basic acceleration equation, or which is V is equal to ET اللي هو بما معناه velocity is equal to the acceleration times time. زين. velocity اليونتس ماله is in meters per second. acceleration اليونتس ماله is in meters per second squared. time اليونت ماله is seconds. تمام. So if you do the math of this, إذا تسوون الماث مال هذا, meter per second يساوي meter per second squared ضرب seconds. زين. And if you remember from math, this is power 1, this is power 2. زين. So this is simply equal to meter second over second squared. Again, this is power 1, power 2. زين. تسوون 1 minus 2. زين. بيبقى لكم meter second 1 minus 2 اللي هو meter second minus 1. Alright. شو معناته؟ معناته الميترز per second مال velocity. زين. this meters per second مال velocity is equal to meter second minus 1, which is meter per second, مال acceleration times time. This is what they call dimensional analysis. فهني this is what we are doing as dimensional analysis. لا يخربطكم وايد الموضوع. All I did was just simplify units, زين, to see if the left hand side is equal to the right hand side. فقاعد أشوف the velocity on the left is equal to the velocity on the right, the units on the right. and if it's correct معناته we have correct dimensional analysis. معناته this equation is correct. ما نقدر نكتب لكم equation مثلا v squared is equal to at. ليش؟ لأن بعدين الجواب بيطلع لنا meter squared per second squared is equal to meters per second, which is wrong. زين ما يستوي شيء squared يساوي شيء بروحه، أو ما يستوي الجواب يطلع لنا مثلا ما نقدر إحنا نقول length is equal to time. ليش؟ لأن length ما يخصه في التايم. length is in meters and time is in seconds. فهاي فكرة dimensional analysis. These are not equal. So we cannot say that this is equal. This is just the basics of dimensional analysis. This is إذا كان عندكم any equation and you know the units of each variable بس بتحطونهم في equation and you will start solving عشان تتأكدون إن left hand side is equal to the right hand side. Now, let's go into unit conversion. Then, this is, in my opinion, one of the most important things you have to know. Most of the time, this is what you will do in almost any case. ولازم تفهمون كيف استخدامه ومتى تستخدمونه بشكل عام. ففرضا عندنا 1 أو let's say 15 centimeters. زين. This is not in standard units. We need to convert it to reach the standard units. شو معناته؟ معناته إن إحنا عندنا سنتيمتر هني. Alright? إحنا we want to turn this into something that is in meters. Alright? فالسنتي 1 سنتيمتر. Alright? أو لازم أقول 1 متر يساوي 100 سنتيمتر. تمام؟ هذا الشيء لازم تحفظونه over time طبعا، بس أظن بيعطونكم هاي في الامتحان. I'm not exactly sure if they do or not، بس لازم تعرفون الكونفرجن على الأقل مال السنتي مال الملي which we'll go over in a bit as well. البيسك units. ف 1 متر يساوي 100 سنتي which most of you guys know. ف how would you do the proper way? How would you do the conversion هني؟ فتعرفون 1 متر is equal to 100 centimeters. ف 15 centimeters you will multiply it by احنا نبغى الجواب يكون in meters, so we will keep the meters at the top. احنا نبغى نكنسل السنتيمتر. تمام؟ فبنخلي سنتيمتر تحت ونعرف 1 متر يساوي 100 سنتيمتر. This way السنتيمتر and centimeter will cancel and you will be left with 15 over 100 meters. Alright? This is how you would always solve for unit conversion. أنا دائما أستخدم هالطريقة عشان ما أتخربط. مرات you can forget if you have to multiply or you have to divide. That for me till today is very confusing sometimes. It happens a lot. فأنا I always follow this rule of thumb and I make sure أن I am doing it in the correct way and getting a correct final answer. فهو بيساوي 0.15 meters. If you have your own method which makes it easier for you guys, go ahead, you can do that. That's fine. There's nothing wrong with that. But just make sure and you know how to do unit conversions properly. فهني عندنا 1 meter is equal to 100 centimeters. We also know that 1 meter is equal to 1000 millimeters. زين. And then 1 kilometer is equal to 1000 meters. زين. When we are looking at speeds, it's the same idea. يعني إذا عندنا speed is the same thing. It's also in meter. Let's talk about time. Time is very simple as well. And then 1 minute is equal to 60 seconds. 1 hour is equal to 60 minutes. Everyone should know that by now. وعادة ال 1 hour حتى directly نكتب is equal to. Actually, let's use this as an example. الحين احنا عندنا 1 hour. Alright? We want to find it in seconds. تمام? How would we do this? We would write 1 hour and we will convert it into minutes. فبنضرب. We will convert into minutes فوق hour تحت نعرف ان المينت اور هو هني 1 hour is equal to 60 minutes، فبنكتب 60 فوق لان 60 minutes is in 1 hour. تمام. times الحين احنا we want to convert minutes into seconds، فبنحط seconds فوق والminutes تحت لان this is the last answer we want. فعندنا seconds over minutes اللي هو هني relationship مالهم، فبنحط 60 seconds فوق وال1 minute تحت. إنزين. and then you will just cancel out the hour with the hour and the minute will cancel with the minute، فبيبقى لكم الجواب in seconds، فبيستوي 1 times 60 times 60 which is equal to 3600 seconds. فبنعرف إن 1 hour is 3600 seconds. Sometimes you could يعني later on you will see that you use this instantly in conversion لأن it just makes it so much easier, so much more direct. تمام. There is also two more units that I want to talk about. عندكم الكيلو اللي تكلمنا عنه. Let's talk about newtons الحين, which I will explain later what newtons is. But just as a unit, kilo, زين, 1 kilo newton is going to be 1000 newtons. زين. 1 mega newton, I'm not sure if you're going to see this a lot. Mega هو capital M. This will be 1 million newtons. زين. Another way of writing this is 10 to the power of 3 newtons, and this is 10 to the power of 6. من وين ال 3 وال 6؟ ال 3 is the number of zeros. نفس الشيء. ال 6 هني is the number of zeros. That's all it is. زين. newtons. Okay, that's pretty much it for the conversion. This you guys need to practice a lot بصراحة من صوبكم انتو. يعني I can only explain the concept and do a couple of examples my way, but you will only get better at it if you practice yourself. So this is just the basic يعني numbers and basic conversion and basics of units. Let us get into actual theory of physics. زين. Let us start talking about forces. So in physics, we have something called mass, which everyone knows by now. And then something that is called weight. تمام؟ الماس هذا يكون in kilograms. الويت هذا, which you will see later on, is going to be in newtons. These are not exactly the same thing. These are not equal to each other. الماس هو الوزن مال أي حد. الوزن اللي تشوفونه يوم تروحون على سكيل توقفون تشوفون وزنكم. This is the mass. إنزين. Which is measured through a scale. إنزين. It is always constant. يعني it is never changing الماس. الماس will always be the same. تمام. الماس depends على الatoms اللي فيكم. It also depends on the size of the object. It depends on a lot of things. الويت is a force, is a type of force. زين. It is not يعني a constant. It is not a scalar value. It is a vector. يعني it has a direction. It has a magnitude. It is not بس a magnitude like mass. زين. It has both a magnitude and a direction. يعني الويت بيكون دائما على حسب الجاذبية مالت الأرض اللي احنا عليها. In this case, our gravity is always the same. It's constant because we're on Earth. But if we are going to other planets and we want to calculate weight, mass will be the same, but the weight will be different. So weight is a force. تمام? And the weight W is equal to the mass times the gravity. So this is the weight is equal to the mass times the gravity or gravitational pull. زين. الجرافيتي on Earth زين G is equal to 9.81 meters per second squared. لأنه what is gravity? It's an acceleration. يعني it is a specific speed you are moving towards the earth إنزين or a specific acceleration. يعني لو انتوا تحت من طيارة إنزين تبون تروحون parachuting تنقزون من الطيارة you're going يعني when you jump out of the plane you're falling towards the earth and you're gaining more speed and speed. You have an acceleration. So this is due to gravity. إنزين gravity's direction is always downwards. It's always towards earth. إنزين so the weight is also always going to be in the direction downwards. Then it's always going to be towards Earth. And mass has no direction. It is just a value. And this is the most basic force that we have on Earth, which is the weight force. And it is always going to have this equation where it's mass times gravity. Gravity will almost never change. It will be 9.81 unless the question is saying, for example, find the mass or find the weight of something on the moon or on Mars or on on a different planet. That is the only time the weight will change. إنزين. Let's see if I can find some questions about weight specifically. It is very straightforward. It is very direct concept. إنزين. Weight, if you want to draw it يعني مثلا this is how you would draw it. يعني عندكم مثلا a box. This is what we call a free body diagram that we will draw now. بيكون عندكم الweight go pointing downwards over here. It's going to be at the center of the box and it will be pointing downwards. This is the weight. Now, an additional force that is always available when there is a surface, يعني الحين let's say that this is on a table, okay? This box is on a table. Right? Box. بيكون في something called a normal reaction force to the weight. يعني بيكون في force من الطاولة إلى فوق. يعني from the table upwards. We call this usually the normal force or the force N. زين? This normal force in the case of if the body is not moving, in this case the box is not moving, this normal force will be equal to the weight. This is just the reaction force of the table holding up the box. يعني التable الطاولة, the table in front of you now, if you're sitting on a table or anything, if you have a laptop on it or if you have a calculator on it, that calculator is not falling through the table due to the force of the gravity, لا اللي هو for weight force. There is something holding it up. This force that is holding it up is called the normal force. In the case of when the surface is flat and the box is not moving, the normal force is going to be equal to the weight. إنزين? This is what they usually call equilibrium. إنزين? This is what they usually call equilibrium. معناته the forces are going to be all equal بما معناه. Or I should say the sum of forces is equal to 0. زين, and we will look at this a bit more in a bit. زين, فهني في هالحالة we have this normal force, and this normal force is going to be the reaction force to the weight or to the flat surface. زين, يعني any surface بيكون له normal force pointing upwards. تمام. That's pretty much it when it comes to gravity and forces, the basic forces. All right. Now let's talk about the same box. زين. Let's say if there is going to be someone pulling this box. So there's a piece of rope هني. زين. There's a piece of rope هني and someone is pulling this box. فبيكون عندنا a force over here as well. زين. A force, let's call it F. So when we are pulling this box to the right, بيتحرك شوي شوي صح ولا لا؟ أو ما بيتحرك على حسب الأرضية إيش كتر خشنة. So this is what we call friction, which we will look at later on. But let's consider for the sake of this example, this is a smooth surface, meaning there is no friction. meaning what meaning إنه it is يعني ما في anything on the كأنه it is كأنه it's like ice إنزين an icy surface, it's very slippery, it's super slippery and it will never stop the motion of whatever is moving on top of it. So let's call this a smooth surface. This force F will be moving at a specific direction إنزين in a specific direction. It will have to have an acceleration معناته. What does this mean? معناته الحين البوكس is moving, all right? The box is moving in this direction with a specific acceleration. بيكون في له acceleration اللي هو in meters per second squared. إنزين نفس ما هني عندنا gravity which is moving downwards in this direction in meters per second squared. زين الحين عندنا acceleration to the right لأن البوكس قاعد يتحرك, so we're moving the box. So since the box is moving, there's going to be an acceleration in the same direction as the force. So from this we know Newton's second law can be applied, which says that any force F is equal to the mass times the acceleration. I'm pretty sure you've seen this equation a lot. فالmass is in kilograms and the acceleration is in meters per second squared. All right, for the force is going to be in newtons. Newtons is the standard symbol or standard unit for force. So we know that Newton is equal to kilogram meters per second squared. If we just multiply here the kilogram and meters per second squared, this is the same thing. So we know that Newton is equal to kilogram meter per second squared. This is the rule that will be applied for everything. If you notice, for weight, it is the exact same rule. The weight is equal to the mass. The weight is equal to the mass times gravity. Gravity is our acceleration in this case. Then mass is the same. So this force is a standard force that we call weight. That's the only difference. Then, but this is the more standard form of this equation, which is Newton's second law. Force is equal to the mass times acceleration. So this is how we will know that there is a force here. There has to be an acceleration. وبنضرب هالاcceleration في الماss of the box itself that is moving, and we will see that in a few examples soon. And then so this is يعني what we call the Newton's law of motion. This F is equal to ma. Let me see if I can find an example here. Do you guys have any questions about what I explained so far until I find an example? Let me solve this problem. I'll just make up a problem here. عندنا زين another box over here. It is on a flat surface. We know that the mass is equal to 300 kilograms. تمام؟ وعندنا someone pulling this box over here with a force of 1200 newtons. زين؟ And someone else, or two other people I should say, are pulling the box from here. One guy is pulling it with 400 newtons and another guy is pulling it with let's say 850 newtons. تمام؟ فعندنا بوكس زين وزنه 300 كيلو، في شخص هنا قاعد يسحبه زين، و there are two other people are pulling it in the other direction. Now طبعا بيكون في acceleration but we do not know where the direction is. ليش؟ لأنه we have three forces here. We have F1 over here, we have F2 and 3 over here, this is F3, and we have F2 over here. زين. Today we will cover inshallah the topics up to, I will try to friction, but I will focus up to moments mostly. So most probably I'll finish up to moments today. Now, let's continue this question. If we have a force on the right and a force on the left, these are opposite in direction. زين. First thing we have to do is we have to set our positive direction. لازم نختار a positive direction for ourselves to analyze it. You can choose left or right, it doesn't matter, but you have to choose a direction to be precise. Fair? And I will just choose the right direction to be my positive direction. Positive direction. تمام? So now F1 is positive. Plus 1200. F2 is minus 400. زين newtons طبعا newtons. And why is it minus? Because it's in the opposite direction of my positive direction, so it's negative. F3 is minus 850 newtons. Again, the positive direction, you can choose it in any way. You can choose it to the left or to the right. زين. Yes, I will be sending this paper to you guys after the session, inshallah. زين. Now, remember what I said earlier. The summation of forces, for this to be, to find out the total force, we need to do the summation of forces. Don't let this scare you. When you see this, all this means is you are going to add F1 plus F2 plus F3. This is all this means. And you will add all the forces together. This is what the summation of forces is. So it's going to be plus 1200 minus 400 minus 850, which is equal to 1200 minus 400 minus 850. الجواب يطلع minus 50 newtons. شو معناته minus 50 newtons now? If we go back here, we found that the total force, we found that the total force is equal to minus 50 newtons. معناته we know the direction of the final force is in this direction. And it is equal to 50 newtons. معناته if I redraw this, if I just redraw this, we don't need any of these anymore. We know that the total force acting on this, هذول كله يكنسلون الحين بعض ويبقى لنا شو اسمه 50 newtons to the left. Why is it to the left? لأنه we got F to be هذا sigma F to be minus 50 newtons. زين? And we chose our positive direction to be to the right. Since it's minus, it has to be in the opposite direction. And the value is of 50 newtons. So now we know the direction of this box. We know it is going to have an acceleration in this way as well. زين? So we're going to have an acceleration this way. And we can find this acceleration. Why? Because we know that F is equal to M times A. All right? If we do some basic rearranging, we have F and then an F and then an M, but we need to find the acceleration. So it is going to be 50 is equal to 300 times A, which we need to find. زين? So A is going to be equal to, we are just going to divide by 300 on both sides. So it's 50 divided by 300, لأن 300 here will cancel. So acceleration is going to be equal to 50 divided by 300, which is 1 over 6. بما معناه acceleration is 0.167 meters per second squared. So we know that this is now the acceleration of this box going to the left. This is how we calculate it. المفروض minus 50. Okay. The minus, you are correct. You could put the minus هني, but I already have determined the direction. All right. Let's say I did not determine the direction of acceleration. This is a good point. This is a very good point. Let's say هني احنا ما قررنا وين direction. We know that it has acceleration. We just don't know in what direction. Since we have not determined the direction, we have to keep the signs everywhere. So this will become minus. هني this will become minus. And this will become minus 1 over 6. فالجواب بيطلع لنا minus 0.167. This is if we do not already determine the direction earlier on. We already know it has to go to the left لأن the force is going to the left. But let's say we did not mention that direction. So we know the force is minus 50. We're going to put it as minus 50 because we didn't determine the direction. جوابنا طلع in the minus. لأن جوابنا طلع in the minus, this is where we decided our positive direction to be. So we know that the direction of the acceleration will be in the opposite way, and it is going to be 0.167 meters per second squared. All right? This is a very good question. So the minus is only to determine the direction. This is the idea. And what I did is I instantly decided that the direction will be in the same direction as the force because it makes sense. If the force يعني is going towards the left, it has to be accelerating towards the left. That's why I ignored the sign in that case because I already mentioned the direction. If you do not mention the direction, you need to keep the negative sign so that it will show you the direction at the end. All right? إذا ما تعرفون direction, always keep the units, the sign. The sign is only there to show you the direction of the force or the acceleration. تمام? Yeah, this is pretty much it for this question, I believe. Let's see if I can add any extra thing to it. Okay, let's say what is the weight of this box? زين? We never checked what the weight is. So the weight is going to be downwards. تمام? Weight. What is the weight of this box? Weight is equal to mass times gravity. Gravity is given to you as 9.81 meters per second squared. Sometimes they might tell you that gravity is equal to 10 meters per second squared. This is normal عادي يعني. It depends on the question what it asks. Just follow whatever is written in the question as for gravity and you will use that. For the weight will simply just be 300 times 9.81 meters per second squared. Then this is kilograms. For the weight is going to be 300 times 9.81, which is 2,943 newtons. And then it's a very heavy box. Now tell me this. We found the weight. What is going to be our normal force equal to? What is the normal force equal to? I want you guys to answer in the chat. What is our normal force going to be equal to? It's going to be exactly same as the weight. You are all correct. The way to do this, the proper way to do this is we will say sigma Fy. All right, it is equal to the weight. Earlier on, we did sigma F. This is sigma Fx. What does this mean? عادة in physics, زين, we have an axis. صح? We have X and Y axis. So this is what we will call the positive X. And this is what we can call the positive Y. زين? For early on, when we were looking at forces, they are along the x-axis. So when we did the sigma of F, we did sigma Fx, اللي هم the forces in the x direction. Now we are going to be looking at sigma Fy, which is the sum of forces in the y direction, which is W plus N. All right? W plus N. I will explain this in a bit. And then, so here we know that W is downwards and we decided our positive direction is to be upwards. So we know that W is going to be minus. Why? لأن our gravity is going to be minus because gravity is also in the downward direction. So gravity is going to be minus. When you're multiplying, you will get a negative answer for W. تمام? Is the box moving along up and down? No, it is stationary. It is still. It is not moving up and down. It is only moving left and right. But up and down, it is on a flat table. So it is not moving. So the total acceleration, the total sigma Fy is equal to 0. This is all equal to 0. Why? لأن sigma Fy is equal to mass times acceleration. There is no acceleration up and down. The total movement is 0. So the acceleration is 0. Therefore, sigma Fy is equal to 0. تمام? This is how you know if there is motion or there isn't motion. If the acceleration is 0, there isn't going to be any motion. معناته the total forces have to be at equilibrium, which is equal to 0. This is what we mean by at equilibrium. تمام? So W plus N is equal to 0. W we know is minus 2,943 newtons plus N is equal to 0. So now we could just solve for N. We could just take the W to the other side. And you will realize that N is equal to plus, since it's minus here, it's going to become plus there, 943 newtons. So now we know, we already knew that the direction was going to be upward, so the answer had to be plus. But now we know that N is equal to W in this case when we do it the proper way. يعني here we all just figured it out instantly. But in this case, we realize this is the proper way of proving it. So now there's a question in the chat and I want you guys to answer this question. إنزين? Based on what we just learned هني with sigma Fy. When is W not equal to N? When is W not equal to N? Based on what I just explained from this and this, when is W not equal to N? I need an answer from your side, please. Allah, think about it. When is W not equal to N? إحنا هني we said this is at equilibrium. That what? Acceleration is 0. So W is not equal to N when acceleration in Y is not equal to 0. When there is motion. Exactly. إنزين؟ معناته, for example, let's say عندنا an inclined surface and we have a box on top of it here. All right. Now our normal force is going to be in this direction. زين لأن the normal force is always perpendicular to the surface it is at. While our gravity is always going to be downwards. So here, as you can see clearly, this is N and this is W. N is not equal to W. All right? So AY meaning يعني any vertical motion, any motion along the y-axis. هني we obviously will have motion in the y-axis. Why? لأن this is going to go travel downwards over here. فبيكون يعني في motion in this direction and there's motion in that direction, which we will see in a bit, which is the resultant of forces in general. إنزين there is motion in the vertical way. It is going downwards at the end of the day. It is moving both left and down. So it is moving in both axes. معناته there is motion in both axes. It's not at equilibrium at any point. تمام? This is when W is not equal to N. Or if there's just generally motion in the Y. يعني let's say that this item is on an elevator, for example, in an elevator. زين. This item is in an elevator. زين. This looks like an oven, but let's say it's an elevator and it's going upwards. مثلا. هني there will be acceleration. So if it's going upwards, there is an acceleration. So A is not equal to 0. Even though the normal force is in the same direction upwards and weight is downwards, and then the normal force is going to be larger than the weight. They're not going to be equal. تمام? Why? لأن هني we have an acceleration. We have an acceleration. I don't know why I highlighted it in red, but because we have an acceleration. So if we solve, let's solve this example. إنزين. Let's say that the weight is the same weight as we have, the same box. إنزين. So the weight is minus 2943 newtons. وعندنا an acceleration, a small acceleration of 1 meters per second squared. زين, very basic small acceleration. So we know that the mass of the box is 300 kilograms. M is equal to 300 kilograms. And we are saying up is the positive y direction. All right. Let me just close this off. هني عشان تعرفون what we're working on. هني now we have this elevator that is going upwards. زين. في حبل قاعد it's pulling it up and it's going upwards at this acceleration, and we have the same box, so we have the same weight. Let us apply the force equation, the sigma Fy equation. So sigma Fy is no longer equal to 0. What is it equal to? It's equal to the mass times acceleration. Acceleration is no longer equal to 0. We know that sigma Fy is equal to the mass, which is 300, times 1 meter per second squared. For we know that the sigma Fy is going to be equal to 300 newtons. صح ولا لا? 300 newtons. This is what we did. We just multiplied 300 by 1. Now, we found our sigma Fy. We also know that sigma Fy is equal to W plus N. So now it is no longer equal to 0. It is equal to 300 newtons. We know that W is minus 2943 newtons plus N is equal to 300 newtons. All right. Now we have a sigma Fy in a direction, in an upward direction. It's positive, so it's in an upward direction. So N is going to be equal to, if we just take this to the other side, then it's going to be 300 plus, since it's minus over here, it's going to become plus 2943 newtons. N is equal to 3.243 newtons. And since it is positive, we know that it is upwards. This is how you would solve it. See now, N, W in this case, is not equal to N. All right? So this is the whole concept of having forces, the normal force and the mg, or the weight force. They're not going to be equal. This is the case. When there's an acceleration, or not necessarily an acceleration, they could also tell you that there is a force being acted on the box. Yani, for example, let's say we have the same box and then a normal force, but they also say that there's another force that is being applied. Let me color code it so it's clearer. So we know that this is our normal force, which is always perpendicular to the surface. And we have our gravity force, or force due to gravity, which is the weight. And they could say, for example, there's a force being applied to the box in the upward direction. This will cause an acceleration. So this, again, in this case, the W is not going to be equal to N. All right. This is the whole idea. At the end of the day, the main concept is, if there is acceleration, there will be they will not be equal. The mg and the gravity, sorry, and the force itself. تمام? The gravity and the normal force. يعني. This is the whole concept of drawing a free body diagram, of knowing how to solve with forces. Let me see if there's one more problem I can find that is going to be a little challenging, عشان we can solve it together. Then, before I move on, did you guys take the laws of motion in class? Did they teach you about the laws of motion, which is V is equal to U plus AT and acceleration, the one I showed earlier, which was v equal at, it's the same thing. Acceleration is equal to velocity over time. This is basically where this comes from. Did you take this basic equation where v is equal to u plus at or no? I just used it in examples انزين. I don't want to cover this لأن I didn't see it in the slides anywhere specifically. I saw it in a couple of examples, but I'm not sure if it's going to be in the exam or not. If it is, I will look at it again some other time. And I just want to focus more on F is equal to MA specifically. I'm going to try to find this a question. And then let's solve this question. So it says a bucket of cement of mass 40 kilograms. Then, so how do I usually solve questions? I always go step by step and write down everything I can find as soon as I find it. Fair. A bucket of cement. What I would do is draw a bucket of cement. Honestly, this is what I usually do. عشان I just get a better idea of the question. Of mass 40 kilograms. So I know this has a mass of 40 kilograms. تمام? I have mass. I know instantly in my head I can calculate the weight. Instantly. As soon as you see mass, just think that, okay, I can calculate weight. All right? Is tied to the end of a rope connected to a hoist. I know هني بيكون في there's a rope connecting this somehow. زين يعني let's say it's like this. It's connecting it from the top to a hoist. Up here. زين. So it's connected to a ceiling, for example. It's connected to a rope this way. Calculate the tension in the rope when the bucket is suspended. Suspended معناته but stationary. Suspended, what does suspended mean? Suspended means that this rope is on a straight line. It is being taut يعني. All right, so it is a tight rope. معناته it is exactly straight. All right, this is how the rope is. This is what suspended means. Suspended means it is being suspended like this from up to down, but stationary. Stationary معناته acceleration, there is no acceleration left and right. يعني it is not moving up and down or left and right. There is no acceleration up, down, left, right. Acceleration all is equal to 0 in all these cases. This is what stationary means. يعني acceleration is equal to 0. That's basically what it means. And they say take G, the gravitational field G, as 9.81 Newton per kilogram or meters per second squared. زين. So we know that G is 9.81. 9.81. Now, let's draw the free body diagram. This is the first step to do to solve a question. This is just a diagram. This isn't a free body diagram. This is just a diagram of what it looks like. So, let's say this is the object. And then, or let's make it a simpler square object, بس عشان it's simpler to draw. We know it's going to have a gravity force, which is downwards. Let's call this W. And we know that there is a tension force upwards that is holding it straight. Let's call this force T. And then it's tension. Usually tension, we will call the force T. You can call it F, it's the same thing. تمام? Now, how do you solve this? Very simply. There's no acceleration anywhere. And then, so we know that sigma Fy, we will consider upwards. And then, this is our positive directions. Upwards for y and right and left for x, even though there's no forces on right and left. So we will call sigma Fy up positive is equal to 0. Usually they would write something like this next to the summation. This is just to show you that they are taking upwards as the positive direction in this free body diagram. That's all this means. And then, so it's going to equal to 0. Why? Because acceleration is 0. There is no acceleration. Acceleration is 0, so the sigma Fy is equal to 0. So sigma Fy is also equal to what? W, or tension, plus W. صح ولا لا? And these are going to be equal to 0. What is the weight? The weight is equal to m times g, which is equal to, the mass is given to be 40 kilograms, times the gravity is 9.81, but keep in mind gravity is in the downwards direction, so it's going to be minus. So minus 9.81 meters per second squared. So the weight is going to be equal to 40 times minus 9.81, which is equal to minus 392.4 newtons. Again, the reason it is T plus W, we are adding up all the forces in the Y direction. We have this force, which is going upwards, and this force that is going downwards. All right. We are considering the direction here with the sign. And we are just adding all the forces to find out what the forces are going to be equal to. Then we know when we add these two forces, there's no motion. So this force up and down, obviously, logically, they have to be equal. لأن there is no motion. All right? Again, I will explain. So we have sigma Fy, which is the sum of the forces in the Y direction. This is what this means. This is the sum of forces in Y direction. Y direction meaning the vertical direction, which we already mentioned here, in the vertical direction. Tamam? So we are just adding up these forces. What forces we have? We have the T force and we have the W force. So we're just adding them up. All right? We're adding them up directly. The direction of them, I will be considering in the signs directly. So when I know that when I look at the direction of it being downwards, it is opposite to the positive that I chose, which is up. It will be a negative force. Same thing with gravity. Gravity in this case, it is going downwards. The reason we are choosing it as upwards is just our choice. يعني إحنا, we just chose this Y over here. We chose this to be our positive direction. We could have chosen it to be the bottom as well. It is up to us where we want to define the direction. But then we need to stick with that direction and solve accordingly. That's it. So we know that gravity is downwards. Since gravity is downwards, it has to be negative also. This is why gravity is minus. It's minus 9.81. لأن it is going in the downwards direction opposite to what we have chosen. That's it. That's the only idea. All right? So again, we're just going to add them up. T plus W is equal to 0. We found the W to be minus 394. So if we just substitute this now, we know that T plus W, which is minus 392.4, is equal to 0. And then, in other words, this is going to be T minus 392, because plus and minus becomes minus, is equal to 0. So T is simply going to be equal to, we take this to the other side, it is going to become plus 392.4 newtons. So they are equal, which makes sense because there's no acceleration. Since there's no acceleration, the tension, the force upwards, has to be equal to the weight of the item. All right? This is just a very simple problem, very direct. Any questions about the basics here? All right. Let us do another question. This is a continuation, actually, of this question. So it says here, the bucket of cement in problem 5 is now hoisted vertically upwards with a uniform acceleration of 0.4 meters per second squared. Yani, this bucket that we drew here, the same bucket, now is being pulled up, hoisted upwards, معناته being pulled upwards. Yani, this is going upwards and it will have an acceleration. And what is the acceleration? Acceleration is equal to 0.4 meters per second squared. Calculate the tension in the rope during the period of acceleration. Now it is different. The solution is going to be different. Why? لأن we have an acceleration. It is no longer in equilibrium, right? So we're going to have to solve it now again. The same method, but sigma Fy now is not going to be equal to 0 because we have an acceleration upward. Because this is being hoisted, معناته it's being pulled up. زين? So let's redraw the free body diagram. So we'll draw it as a box just for simplicity. We have a tension force up. We have mg down, or the weight down, which is equal to mg. We know that gravity is equal to minus 9.81 because we are going to consider upwards as our positive direction. Okay. And now we have an acceleration as well. So when we are going to find sigma Fy, it is going to be equal to m times a. So it's equal to 40 kilograms, which is given, times the acceleration, which is 0.4, which is also given. So now we know that sigma Fy is equal to 40 times 0.4, 16. 16 newtons. All right, this is the acceleration. Now, this is the force, I mean, this is sigma Fx Fy now. So we also know that sigma Fy is equal to tension T plus W, which is now equal to this, not 0 anymore, it is equal to the 16 newtons from this equation. So now we can just solve T plus W again from earlier was minus 300 and how much was it? Minus 392.4. It is the same W. W is just equal to mg. So 392.4 is equal to 16. Then, so T is going to be equal to minus 392.4 equal to 16. T is going to be equal to, we're going to just take this to the other side, so it will become plus 392.4. معناتها T is equal to 16 plus 392.4 is equal to 408.4 newtons. If you notice now, the tension is higher. The tension is 408.4. I don't know why I wrote it as 40.8. 408.4 newtons. زين. If you notice now, the tension is higher, which makes sense لأنه قاعد ينسحب لفوق. ففي ضغط زيادة على الواير. يعني there is more tension being applied to the wire or to the line or to the rope. لأن it is being pulled upwards. So the tension is going to be slightly higher as there is an acceleration in the upwards direction. All right? This is how you would solve such a problem. Let's do one more and then we'll just take a 5-minute break. It is also a continuation to this problem. So now the question says, the bucket of cement in problem 5 is now lowered vertically downwards with a uniform acceleration of 1.4 meters per second. Now keep in mind, all right, احنا هني we took acceleration as positive. Why did we take it as positive? Because it's in an upward direction. And we have decided that positive is going to be upwards, all right? Here in this case, the bucket is being lowered. So if I copy paste this again, right? The same exact diagram that we have here. Now the acceleration is not upwards, this is being lowered, so it's going downwards. And the acceleration is 1.4 meters per second squared. But because we usually say upwards is our positive x, or positive y, I mean, here our acceleration is going to be negative. Then, because it is in the opposite of the positive direction that we are choosing. We draw our free body diagram. We have our weight. We have our tension. Then, and we have our, that's it. We have tension and we have weight. That's it. That's all we have. And we're going to apply the same equation again. Sigma Fy is equal to m times A, which is equal to 40 times minus 1.4. So sigma Fy is going to be equal to, remember this is negative because of the direction. So sigma Fy is simply going to be equal to 40 times minus 1.4 is equal to minus 56 or negative 56 newtons. Again, we know sigma Fy is equal to tension plus weight, which is equal to now minus 56 newtons. Tamam? Again, if we just solve this, tension plus minus 392.4. It's the same weight that we calculated in the first problem. Nothing has changed. The weight will not change. Is equal to minus 56. So tension plus and minus becomes minus 392.4 is equal to minus 56. We take this to the other side to solve for t. So t is going to be equal to minus 56 plus 392.4. So the tension now is equal to 392.4 minus 56. 336.4 newtons. Now if you notice the tension is lower, أقل من الويت. ليش؟ لأن now we are using, يعني we are letting it go. So we're letting weight do most of the work so that it will go downwards. We're not letting the wire pull it up. We are letting the wire release the tension on it عشان يطيح الbucket. That's why the tension is going to be lower when it's accelerating downwards. All right? Let's take a small break لأن صوتي بتقعد يروح شوي. So let's just take a small break, and then when we come back, we will be covering the moments, which is from week 2. I think this is the most important concept so far of week 1. If I feel like I have missed anything, inshallah, I'll cover it in the moments part and when we come back. Let's take a break until 120. زين 120 شنو؟ let's do 120. Break till 120. تمام? And I don't think we'll cover friction today. Friction will be for the next session. So today we'll cover only up to moments. And I will be back, inshallah, and at 120, and we'll start with moments. If you have any questions, write them in chat. When I'm back, I will look at them, inshallah. Friction would be good if you can cover today. I wanted to, I was hoping I could, but I really wanted to cover forces more clearly. والمoments بعد يعني I wanted to just cover it all fully, properly, and I want to do a lot of questions with moments so you guys can get the concept. I know friction might seem hard, but it's not that difficult. I promise it's going to be easy. And inshallah, by next session, you will have enough time to practice it as well after Eid before your exam. And we will also be doing some questions in the mock test about friction. So inshallah, it will be, yani, I wish we had more time, but unfortunately, this is the situation right now. The problems we just took, are they on forces? Yes, the problems clearly سويناها, they're all about forces. Yes, we have not done anything other than forces. The recordings of the video is going to be posted in the same chat. I'm going to send a link in the chat. This link is going to be a playlist on YouTube for all the videos that I'll be posting. So this one and the future ones that I'll be doing of the recordings, they will be posted as well on the same link. Okay, so I'll be sending it on this Teams chat whenever it's ready. Also, the files that or these notes that I'm writing down will also be sent through the same chat, inshallah. Now, let's look at any other questions before we start moments. All right, so let us begin. So we're talking about forces earlier. Forces is basically, let's say we have I don't know, let's say we have a shelf. زين. This is usually the best example I can say. Let's say we have a shelf. All right. And on this shelf, there are books usually, right? We are always having multiple different types of books over here, different shapes, sizes. And each book has its own mass, its own weight. صح ولا لا? So this is W1, this is W2, and this is W3. All right? All of you should know now what the weights are, and these are all types of forces. All right? Now, these weights, all right, each one will be causing the shelf to want to bend. صح ولا لا? يعني the shelf now, the same shelf, due to the weight on top of it, it is going to try to take this shape. لأن there is weight on it and it is stuck here, so it's going to try to take this shape. صح ولا لا? It's going to be bending downwards. Another simple example is when you have a ruler, a plastic ruler, and you have يعني تحطونه على الطاولة or something, and you put your hand on it on the table, and then you start applying a force. It even makes out the sound, the tark, So when you're applying that force and you're holding your finger on the edge, بتشوفون that it is bending. This is called a moment. You are causing a moment about wherever the point is fixed. So when you're applying a force and يعني on a ruler, or in this case on this bookshelf, when you're applying a force, it is always going to have the tendency to want to bend. يعني هو لازم دائما بيكون له الإرادة إنه شوي ينعوي زين to bend. So this way the the reason it does not bend is usually because this is fixed in the wall with the proper material, or it's a very hard material or a strong material that can counterbalance the moment. This is what they call it. So it will make sure that the moment itself, it will never actually bend. It will resist the bending due to the forces. So this is what moment is. This is what moment is. So the moment is going to look something like that. Moment in that direction. It is bending in that direction. All right. And usually a moment is defined about a specific point. So let's call this point O. So this is going to be the moment at O. Now, each of these books are at a specific distance from the wall. All right? D2, this was D3, and this is D1, distance 1. All right? These are all at a specific distance from the shelf, from the wall, يعني, sorry. زين? So this is the wall. So the moment basically is the moment about point O. This is point O, right? So this is how you would write it. So the moment about point O for all of this, زين? Let's go step by step. So for the green one, the moment of the green book, about O, not sigma moment, it's just moment about O for the green book, so for 3, is equal to the force 3, which is W3, times the distance 3. I will just rename the weights as F so that there's not too much confusion. Yes, they are a weight, but they're also a force. All right, so this is force 1, force 2, and force 3. So it is going to be the force times the distance. What's special about this distance? This distance has to be the perpendicular distance, meaning it will form a perpendicular between the force itself and the point on the wall. All right? So this will be a perpendicular force in all cases. Perpendicular meaning بيكون زاوية 90, meaning a 90-degree angle with the force. All right? So this has to be the perpendicular force distance for it to be correct. The same thing will be the moment about O, around O, يعني point O, for force number 2, it is going to be equal to force times the perpendicular distance, which is D2. And the same thing is going to be again correct for the moment of 1, which is the force of 1 times the perpendicular distance D1. Okay? So it has to be the perpendicular distance. Now, if I want to find this total moment, then if I want to find this total moment, the sigma moment about O, it is simply going to be equal to the moment of 1. So M0, 1 plus M0, 2 plus M0, 3. All right? You're just going to add each moment by itself. But direction is also very important. In this case, all of them are going to have the same direction. And how do I know that? Now, so let's keep this on the side عشان to look at the concept, and let me redraw this one more time down here. So we're going to look at each one by itself now. Then we're going to look at each. Oops. Let's erase all of this. Let's erase all of this. Let's erase this. And then let's look at just F1. All right. Let's look at just F1. So we know F1, this is the perpendicular distance. And then this is the distance D. And the force is vertically downwards. And then let me draw it a bit more accurately. It's vertically downwards. This is F1. We are going to look at how F1 is going. يعني now if I'm looking at the direction, and then we're going to look at how F1 is going towards O. This because we're trying to find the moment around O. We're going to try to connect this as if it is going towards O. It is going in that direction. So it is basically going in this direction. This is known as the clockwise direction. The opposite direction would look something like this. This is known as the counter-clockwise direction. Clockwise meaning يعني going in the same direction as a clock, how the clock goes, you know. And then Counterclockwise will be the opposite direction of what the clock is. So this is clockwise direction and counterclockwise. And usually in physics, clockwise is positive for moments and counterclockwise is negative for moments. And then usually this is the case that is being followed. In your cases in sigma, it doesn't matter which you choose to be positive, but in more advanced cases later on, you will see that there are some specific things where you have to consider clockwise to be positive. But usually what they will write is this. They will draw this thing over here and write positive in this equation up here, meaning that we are considering clockwise to be positive. My recommendation, always do clockwise as positive so you do not forget and get used to a specific method. So how did we know that F1 is clockwise? Because again, we are going to take it, where's the arrow? The arrow, we're going to try to spin it towards O. So as if we are trying to connect it to O, yani as if we're trying to do this. We're taking it, we're going to try to connect it to O. So we are looking at this, which direction is it going? It's going into that direction. So it's in the clockwise direction. And we're going to do the exact same thing again for each and every one of the forces. All right. So that was for the first force. You will notice that they're all very similar. This is F1. We are done with F1. And then we're done with F1. Now let us look at F2. This is F2. This is the direction of F2, or the perpendicular distance, I mean, of F2. And then again, we're going to do the same thing. If you notice, if we're just trying to connect this to the O, it is going into this direction, which is the clockwise direction. So it is positive. All right. So we know that here, this moment is going to be a positive moment. We know that this is plus. All right. Not here, sorry. It's going to be here. And instead of this plus, this is going to be plus because of the moment itself. This is plus because of the moment. This is plus because of the moment. All right. So because of the direction. So we know that the direction is clockwise. And if we look at the third one, it's also going to be the same thing. If you notice, I'm just going to draw it very quickly here. And then you notice that it's also again clockwise, so it's also positive. Let's say we have a different example. So just to finish this, the sigma moment is just going to be M01, M02, M03. M01 is F1 times D1, M02 is F2 times D2, and M03 is F3 times D3. So we're just going to find the total moment around O. We're just going to add all these moments. Why did we add? Because they're all causing the same, the moment in the same direction. Now let's say عندنا لعبة السيسا. ما اتذكر شو يسمونه بالعربي بس you know a seesaw, which is a game like this where you have someone sitting here and then there's someone else sitting here. زين. And if there is a chair like this here and then there's another chair like this here. I know it's not how the chairs usually look like, but it keeps going up and down, up and down. Where is it fixed? This is where it's fixed. So let's call this the point O. All right. So this will keep going up and down in both ways. صح ولا لا? Depending on the weight that is being applied on each side and how much force you are applying to push it up and down. So let's say that a person, which is 5 kilograms, sitting here, not 5 kilograms, let's say 20 kilograms, and then a small child is sitting here, and then a bigger person of 50 kilograms is sitting on the right side. All right. So we know here we have a force due to the weight of 20 kilograms. So it is going to be W is equal to mg. Then, or we could just simply say F1. We'll call this F1. So F1 is equal to mg, which is equal to 20 times 9.81. You know what? For simplicity, actually, let's keep it 9.81. I don't like to use gravity as 10. So 20 times 9.81 is equal to 196.2. newtons. زين. So we know F1 is 196.2 newtons. Let's find F2 here. F2 is going to be the force due to the weight. This is also W2, but I'm just calling them F2 for simplicity. F2 is equal to M2G. This was M1G. So M2 is 50 kilograms times 9.81. So it's equal to 490.5 newtons. Okay. So we have moments on the left. We have a force, on the left and a force on the right. And let's say this is equal in distance, okay? Let's say this is equal in distance. Yani the distance is from here to here, from this to the force, all right? This distance is equal to, let's say, 2 meters. And the distance from here to here is also 2 meters, all right? So they're equal in distance. Now, yes, F is equal to MA. This is W. So, okay. Again, I need you guys to understand one point. When I'm saying F is equal to MA and W is equal to MG, these are exact same questions. Because what same exact equations? ليش؟ لأن G, this G over here, this is known as the acceleration due to gravity. زين. So this is A, but a more standard way of writing it is writing G لأن it is always the same on Earth, which is 9.81. And W, it is a force due to weight, which is due to gravity, to be more specific. معناته it is يسمونه weight. The weight is a force due to gravity. So this is simply saying force is equal to mass times acceleration. It is the exact same thing. It is the exact same equation. هني we know that the force is going to be due to gravity. لأن gravity is what's pulling them down. All right? We know that we have a gravity downwards. And I'm choosing, it doesn't matter about direction here لأن احنا we're talking about moments. So we're looking at the gravity to be downwards. All right? Here, the mass is the same. The force is the weight we are talking about. So this force is same as the weight. And the acceleration is just the gravity, which is the acceleration due to gravity. They're the same units, the same everything, but it's the acceleration due to gravity. Yani A is equal to gravity in this case. That's the only thing. So do not get confused when I'm changing F with W or G with A. And then W is just a more standard way of writing G. Writing F. Yani it is usually standardized for weight, specifically for weight. G is most of the time used for this acceleration when it is due to gravity itself. That is the only thing. But they are the exact same equations, the exact same meanings, just a more standard form. When it comes to weight, this is what they use. Now back to the question. We found our force 1, we found our force 2. We have our distances, 2 meters and 2 meters. So let's start finding the moments for each one. So the moment of F1 is going to be equal to F1 times the distance. All right? So it's equal to, what is F1? F1 is 196.2 newtons. Over here, 196.2 times the perpendicular distance D1, which is equal. So this is the perpendicular distance, because if you notice, if we draw a line here, it makes a right angle with the force itself. زين? It makes a right angle with the force itself. This is what is meant by the perpendicular distance. يعني this distance over here to point O, this is a right angle. تمام? Again, acceleration, you're not going to count it as 9.81. You're not going to count it as 9.8. You're going to count it as per the question intended. Yani the question will say, take gravity as 9.81 in this case, meters per second squared. The question will tell you what to take gravity as. If it is not given in the question, I would not even guess. I would just ask the teacher. Tell him, what do you want me to take as gravity? You want me to take 9.8, 9.81, 10? What do you want me to take? So it is always going to be given in the question. So you do not have to worry about what to take for gravity. All right, back to the question. So the force times the perpendicular distance here, which is 2 meters. All right, 2 meters. We're going to do the exact same thing now or let's just find the final answer مرة واحدة. So 196.2 times 2, which is 392.4. Now, we have force, which is in newtons, and we have distance, which is in meters. So the unit of moment is going to be Newton meter. This is very important to know the unit of moment. It is Newton meter. Why? Because you're multiplying Newton by meter. So it's going to be Newton meter. Tamam? Now let's do the same thing again for the second one, which is moment about O of F2, which is equal to F2 times D2, which is F2 is 490.5 newtons times, just move this a bit to the right, times the distance, which is also 2 meters. As you can see, this is the perpendicular distance, 2 meters of F2. So M0 F2 is going to be 490.5 times 2, which is 981 Newton meter. Tamam? Now, second, yeah, okay. Now, here we have found the two moments, the value of them, but we do not have the sign of them. How do we know which sign it is? We are going to go back to the diagram itself. Let me just redraw this down here. We're going to look at the diagram itself. زين? We don't need the 2 meters. We don't need this anymore. We're just going to look at the forces that we have. زين? This is all we care about now. We just care about the forces. تمام? So we have a force here, F1, and a force here, F2, with a specific value. F1, if you notice, if we want to take the direction, we're going to go towards O. This is the direction we are taking, to go towards O. صح ولا لا? Again, we're going to take the direction, we're going to look at the arrow, and we're going to go towards O. So it's going into that direction. This is known as the counterclockwise direction. It is going opposite to the usual direction. So this is a negative value. Then, if we look at the other one, we're going from here to here. So it's going into this direction. So it's in the clockwise direction, which is positive. Again, this is just counterclockwise. Or sometimes they call it anti-clockwise. It is the same thing. And this is clockwise. All right. So since this is in the clockwise direction, it is positive, and this is in the anti, it is negative. So what can we do? We can simply come here to the answer and say that M0F1 is equal to, in this case, it is, the purple one is negative. So it is minus 392.4 Newton meter. And M0F2 is going to be, we're going to look at the force. It's the blue force. Due to the blue force, it is going in the positive clockwise direction. So it's plus 981 Newton meter. So if I want to find the total moment now about O, this is what we have. All right. This is what we have. We have moment 1 and moment 2. We have one of them as negative, one of them as positive. So sigma moment about O is going to be equal to MO F1 plus plus MO F2. And then you're just going to add all the moments that are about O. So if we write this, this is going to be equal to minus 392.4 plus 981. And then plus and plus is just plus. So this is going to be equal to minus 392.4 plus 981. Put that in the calculator and you will find out that sigma m about O is equal to minus 392.4 plus 981, which is equal to 588.6. And since the answer is positive, all right, this is Newton meters. Since the answer is positive, we know that this is in the clockwise direction. Clockwise direction. This is how you would solve any moment question. All right. Is this clear? This is in the case where it is very straightforward. You are given the perpendicular directions. You are not given any angles. We're going to look at angles in a bit as well now, and we're going to conclude it there, inshallah. But I want to know if you have any questions about the basic concepts so far, about moments. So again, a quick recap. And the moment is just the force times the perpendicular distance, all right? Once you find the force times the perpendicular distance, all you're going to have to do is then find the direction of that moment, whether it is going in the clockwise or anti-clockwise direction. The way you do that is you look at the arrow of where the force is, and then you draw a line going to the point that you're trying to find the moment around, in this case point O, and you will determine the distance, whether it's clockwise or counterclockwise. If it's counterclockwise, it's negative. If it's clockwise, it's positive. Then you will just find, if you are required to find the total moment, you're just going to add moment 1 and moment 2. And this is basically it. You will keep the signs as per their directions. And the sign of the final thing will also determine the direction, if it is clockwise or counterclockwise. Let's see if I can find any specific torque-related question. Just one more point I want to explain. It's more theory. So we have torque and we have moment. Then the difference between these two, okay, this is for something dynamic. بما معناته torque is for something that is moving or you are trying to move. يعني for example, if you have a torque wrench, إذا عندكم nut, right? You have a nut. You have a nut and you have a wrench that you are trying to tighten this, okay? You're trying to tighten it. This is called torquing. This is a torque action. Moment is just the resistance or just the how do I explain it? The moment. The moment is just a static, يعني a non-moving balancing due to a force. اللي هو بما معناه the torque is a moment. A torque is a type of moment, but not all moments are torques. Torque is when you are trying to tighten something, you are causing a moment on it. زين؟ But a moment is just a static thing. يعني it's a thing that exists sometimes, not sometimes, all the times when there is a force that exists. Even if there is no motion, even if there is nothing moving, a moment will exist and it might be cancelled by another moment so that it will be at an equilibrium position. Right? But this is what a moment basically is. It's just a torque is a moment, but a moment is not a torque. A moment is for when everything, whether it is static or dynamic, a moment exists. A torque is just when you are trying to forcefully move something in a rotational direction. عشان you are either tightening or loosening or whatever. All right. Let me find one more example to solve. Let's see here. No, what I'm seeing is all very straightforward questions. يعني I'm not seeing anything that complicated. It's all the same concept that I've shown here. انزين, let's do this one. So here it says calculate the torque supplied by the wrench when an 8 Newton force, inshallah this will be the last question يعني we're going to solve today. So calculate the torque supplied by the wrench when an 8 Newton force is applied as shown in the figure below. فعندنا 8 newtons هني, and we are given an angle, and we are given an angle again. So we have a lot of angles that we're going to have to deal with. It's nothing to worry about. We're just going to go step by step here. I'm going to be explaining many concepts here, so I'm going to take it very slow. I'm going to use up as much time as I can. It's going to be talking about the forces, how to get the forces part, and then how to get the trigonometry of it as well. Insane? So first things first, I'm just going to draw this in simpler ways, in my own way. So we have this wrench, right? And we know that this is 25 degrees. Insane? And then we have the force over here being applied, something like this. And we know that this is, oh, sorry, it's not with that. This is with, okay. So this is something like this, the force. And it has an angle with the straight over here, with the slanted height يعني, of 47 degrees. All right. So this is somewhat of what the free body diagram kind of looks like. We also know that this distance from here to here is 18 centimeters. Okay. Now, هني we're going to start with the force itself. So I didn't cover this topic already, so I'm going to cover it here while I'm explaining this. So when we have a force, we can break down the force into two components along two different axes. For example, إذا عندنا إحنا force in this direction, all right? We can break the force into one in the y direction where the arrows are going to meet. إنزين. So let's call this the force F. This is going to be the force Fy, and this is going to be the force, let's do it in blue. This is going to be the force Fx in this direction as well. إنزين? So Fy and Fx, this is the breakdown or the components of the force F. Excuse me. إنزين? This is what they call breaking down a force into its components. إنزين? The reason we usually do this is to find the moments. Why? لأن in this case now you will see here. So this is, like I said, is breaking down the components. So if we're going to look at this, زين, we have a force F هني. Let's break it down into its components based on this, which is, I will just copy paste this down over here. عندنا بيكون a force that is perpendicular to the surface. We will call our Fy. And then we're going to have a force that is parallel with the surface. We will call Fx. Remember, we are trying to find the moment around the nut. Then this is the nut over here. We're trying to find, this is going to be our point O. So this over here is our point O. All right. This over here is the point O, which is down here. إحنا, what was our rule to find moment? Our rule to find moment is we need the force and the perpendicular distance. So for the green component, زين, this is the perpendicular distance. صح ولا لا? From here to the force to O, this is the perpendicular distance. So we have a perpendicular distance of 18 centimeters. So we can find that. Now, what about f of x? Where's the perpendicular distance between f of x and O? It does not exist because it is on the exact same line as point O itself. So the perpendicular distance of f of x is equal to 0. Whereas the perpendicular distance هني is equal to 18 centimeters. All right? So f of x does not have any effect of the moment at O. It does not cause any turning motion around O. And that makes sense. يعني think of this as a pen. يعني put your pen along this line, right? This line, put your pen along it now. If you put your pen along it, you want to rotate your pen, you have to apply a force in this direction, okay? Or from the bottom to the top, okay? But if you apply a force to the pen like this, the pen will just simply slide down, all right? And it will not be rotating. It will move in a straight line. So this will cause no rotation because it's acting at the pen exactly. So this f of x force has no moment about O, but the Fy force will have a moment about O. Again, these are just components of the main force F, which was given to be 8 newtons. Now, how can we find these components Fy and Fx? So it looks something like this الحين, and this is Fy and Fx. All right. في السؤال it is given that this is 47 degrees. I am going to show you the shortcut that I usually do because the main concept will be explained inshallah in trigonometry on Sunday in technical math. But here I want to just show you the basic concept of how you could do a quick shortcut when it comes to forces specifically. Then you guys should already be familiar with your trigonometry, with your SOHCAHTOA and all of that. Quick refresher, if you remember SOHCAHTOA. Then these are all separate entities. يعني this is a separate part, this is a separate part, and this is a separate part. But this is just a way to remember them. O is opposite, H is hypotenuse, and A is adjacent. So we were gonna, in the shortcut, we're gonna apply somewhat of a similar concept. All right. So احنا, if we're looking at the force Fx, the angle given is adjacent to the force Fx. So since it is adjacent, we are going to know that cosine, so Fx is equal to F, which is the force, the given force F, times cosine of the angle, which is 47 degrees in this case. And for Fy, since the angle is opposite, all right, we are going to go with the, since the angle here, 47, is opposite to it, this is just a way of doing it in a shortcut. The angle is opposite, we are going to use the sign instead. So it's equal to F sine 47 degrees. How so? لأن look at f of x زين is equal to f cosine 47 degrees. ليش؟ لأن f of x is adjacent. This angle now is adjacent. صح ولا لا? So this is an adjacent value. The angle is adjacent to it. In this case, the angle is opposite to it. Where do we have the opposite? The opposite is in sine. So the opposite, Fy, is going to be here in sine. The adjacent value, where do we have the adjacent? In cosine, the ka. So cosine is the adjacent value. So for f of x, it is going to be here, which is cosine. And obviously, you're going to multiply by f. This is just a shortcut that is used. I will be going through the actual proper explanation in the math part, in technical math later on, in trigonometry. But this, for now, I need you guys to understand, and this is a good shortcut to use for forces, specifically for forces, when you're trying to find the components, to find the values of it. Now, we do not care about f of x, we only care about f of y, because f of x has a distance, a perpendicular distance of 0, so it has no effect on the moment about O. So we need to calculate f of y. F of y is equal to F, which is 8 newtons, cosine 47 degrees. So F of y is going to be equal to 8 cosine 47, which is 5.46 newtons. All right. So we found our Fy component that has a perpendicular distance from O. Now I'm just going to redraw this again just to show you how this is going to look like. Now, the only thing that matters for the moment, we do not need the red force anymore. We do not need the blue force anymore. All right, we are done with these. We do not need them anymore. We do not need this angle anymore. We just know that we have a force here, Fy, that is causing a moment, and the distance is 18 centimeters, the perpendicular distance from O. All right? Now, remember, listen. Remember that we have a what's it called? Remember that we have now to find the direction of this direction. We know that the direction is going to be going towards O like that. So we know that the direction is clockwise. All right. So we know that the direction is clockwise. So it's going to be a positive value. But one thing we need to make sure of is, you see here, we are given this in 18 centimeters. This is where you need to know 18 centimeters. We need to convert it into meters. Remember that when you are solving, everything needs to be in the standard units. Then, so this is going to be equal to 18 centimeters. You're going to multiply by 1 meter up, 100 centimeters down. So it's going to be equal to, if you just do this multiplication, centimeter and centimeter will cancel, you will be left with 0.18 meters. So we're going to have to convert this into 0.18 meters. All right. So this is 0.18 meters. Then we can solve for the moment now of f of y. So the moment about O, the moment around O is going to be equal to Fy times the perpendicular distance, which is equal to Fy, we found it to be 5.46. Sorry, Fy is sine. I don't know why I wrote it as cosine. This is sine. I just noticed that. Okay. So it's going to be sine of 47. Sorry about that. So if I just recalculate it again, 8 sine 47, it's going to be 5.85 newtons. All right. Sorry about that. So it's 5.85 newtons. Times the perpendicular distance, which is 0.18. So the moment is going to be equal to 1.05 Newton meter. And in which direction is it? It is in the clockwise direction. All right. So again, the reason this is sine is because we are following this rule over here. Then the opposite and adjacent. The angle given is this area, this location. This is the angle over here, 47. All right. If you remember SOHCAHTOA from triangles back in the day, SOHCAHTOA, we have opposite, we have adjacent, and we have the hypotenuse. Okay. If we want to find f of x, the angle is adjacent to f of x, so we are gonna use the cosine rule because c is adjacent and hypotenuse. If we're trying to use f of y, the angle in this case is in the opposite of f of y. It's not next to f of y. All right, so we're going to use opposite. So it is the sign that we are going to use. This I will explain more clearly, inshallah, in trigonometry and technical math later on. So make sure you focus on that. I will also send a link of me explaining this all very clearly in Math 1 for Engineers, I believe, at some time. If I find the link for that video, I will send it to you as well. And this session is now concluded. I'm sorry I took a bit more of extra, يعني a little bit more extra time. الريكوردينج